Here is the final problem of quadrilaterals. Quadrilateral ABCD is a trapezoid. We know that AD is 15, AB 50, BC is 20, and the altitude is 12. What is the area of the trapezoid? So here we're trying to find the area of the trapezoid. Do you remember what is the formula to find the area of a trapezoid? Well, the area of a trapezoid is equal to 1/2 times its upper side and its bottom side. So I'll write A plus B times the height. Let's see how many of those values we know right now. Do we know its height? Well, yes, we do know its height, and that is 12. We also know its upper side, which is 50. So all we have to do now is find B, the bottom side. How can we find the bottom side? Well, as you can see, DC, the bottom side of the trapezoid, is larger than 50, the top side, which means that it has to include 50. So if we just moved AB down, we will see that it intersects with the bottom in this segment right here. This is 50. But there are some extra spots where we don't know the length of, and that's what we're trying to find. So how can we find the lengths of those areas? Well, as you can see, we have created two right triangles by drawing these two blue lines. And whenever we see right triangles, the first thing that comes up should be the Pythagorean theorem. Again, the Pythagorean theorem is a squared plus b squared is equal to c squared. Let's see if we already know two of the sides of each of these right triangles and try to see if we can find the third side. Let's start with this triangle here. We know the hypotenuse is 15, and if we just moved this over, we know its height would be 12. So we're just trying to find this smaller area here. Let's call it x, and we'll call this y. X squared plus 12 squared is equal to 15 squared. X squared plus 144 is equal to 225. Therefore, x squared itself is equal to 81. Now, x can equal positive or negative 9, but because we're working with geometry, x has to be positive. Therefore, x is equal to 9. So x is equal to 9. Now let's take a look at this other triangle here. We know that this is 12, and y squared plus 12 squared is equal to 20 squared. That means y squared will have to equal 400 minus 144, which that means y is equal to the positive square root, which is 16. Now we know the lengths of x and y, which are respectively 9 and 16. So adding up 9 plus 50 plus 16, this gives us 75. So now we have all of the values needed to plug into this formula. Now let's do that. 1/2 times the upper side 50 plus the bottom side 75 times the height 12 gives us 6 times 125, which in the end gives us 750. So the final area of the trapezoid is 750.